Welcome to our channel. Today we are going to learn about a very important concept in chemistry called oxidation number or oxidation state. So by the end of this lesson, you will be assigning oxidation numbers for compounds, molecules, and so on. So let us define what oxidation number is. So oxidation number is simply the number which is assigned to elements to show how many electrons were lost or gained when bonded. So a positive number means electrons were lost, whereas a negative number means electrons were gained. For example, let's take sodium chloride. So remember from our previous lesson that the shell configuration of sodium is 281 and that of chlorine is 287, right? So for sodium to become stable, it has to lose one electron, right? Therefore, the oxidation number of sodium would be what? Would be +1. And for chlorine to become 8, it has to gain one electron, right? Therefore, its oxidation number becomes -1. So these numbers that are assigned to an element when it is combined with another atom is called an oxidation number. So these numbers can be integers, including 0 and fractional numbers. There are golden rules for assigning oxidation numbers. So the first rule says the oxidation number of a free and uncombined element is 0. For example, sodium, beryllium, potassium, lead, hydrogen, oxygen, phosphorus. All these elements have an oxidation number of 0. So in case of hydrogen, oxygen, or phosphorus, the reason why the oxidation number is 0 is because, remember, these atoms, hydrogen, oxygen, phosphorus, have a covalent bond. Actually, it's called a nonpolar covalent bond, right? So this type of covalent bond, or this type of bond, is formed by sharing electrons equal. So that means these bonds are formed by neither losing or gaining. Hence, the oxidation number of this is equal to 0. Rule number 2. The oxidation number of a monoatomic ion is equal to the charge of the ion. So, if you have a monoatomic, meaning an ion that contains one atom, the oxidation number is equal to the charge of the ion. For example, let's take lithium. Lithium has a charge of +1. Hence, its oxidation number will be what? +1. Iron +3 has an oxidation number of +3. O2- has an oxidation number of -2, and so on. Rule number 3. The oxidation number of group 1a elements is always +1. So group 1 elements include lithium, sodium, potassium, cesium, and so on. So all these have an oxidation number of plus 1. The fourth rule says the oxidation number of group 2A elements is always plus 2. So group 2 elements such as beryllium, magnesium, calcium, barium, and so on. So all these elements have an oxidation number of plus 2. Rule number 5. The oxidation number of oxygen is usually minus 2. So there are instances where the oxidation number of oxygen might be different from minus 2. This case include in hydrogen peroxide, the oxidation number of oxygen is minus 1. In superoxides, the oxidation number of oxygen is minus 1 over 2. In oxygen difluoride, its oxidation number is plus 2. Elemental oxygen has an oxidation number of 0. So let's see one by one. Sodium peroxide. So what is the oxidation number of sodium? In this case, remember rule number 3, the oxidation number of group 1A elements has always plus 1, right? So let's assign the oxidation number of oxygen to be x because we don't know what the value of x would be. So 2 times plus 1 is plus 2 plus 2 times x is 2x. And the sum of this should be 0 because it's a neutral compound or molecule. I say it's a neutral compound. Therefore, 2x equals minus 2 over 2 over 2, x equals minus 1. So remember, one of the exceptions is in peroxides, the oxidation state of oxygen is minus 1. Potassium superoxide, KO2. Similarly, the oxidation state of potassium, which belongs to group 1, A elements, is plus 1. And let's also assign this x, and plus 1 plus 2x equals 0. 2x equals minus 1 over 2 over 2. Therefore, x will be minus 1 over 2. So this is the second exception to the rule. Therefore, in superoxides, the oxidation number of oxygen is minus 1 over 2. Alright, oxygen difluoride. So let us assign x for the oxidation number of oxygen, and when fluorine has minus 1 oxidation, therefore x minus 2 times minus 1 is 2 equals 0, x equals plus 2. So this is also another exception. where the oxidation number of oxygen is different from -2. So other than this, the oxidation state of oxygen is -2. Rule number 6. The oxidation number of hydrogen is +1, except when it is bonded to what? Metals, where its oxidation number is -1. For example, sodium hydride. So hydrogen is bonded to a metal, which is sodium. Therefore, the oxidation state of hydrogen would be what? -1. But in this case, the oxidation state of hydrogen in this case is what? Is +1 because it's not bonded to a metal. Rule number 7. The sum of the oxidation number of all the atoms in a neutral compound is 0. So what does it mean? For example, in magnesium oxide, what is the oxidation number of magnesium? Remember, rule number 4 says the oxidation number of group 2 elements has always an oxidation number of +2, right? Exactly, so +2, and the oxidation number of oxygen is usually -2. Therefore, in this case, it's -2. So +2 plus -2 gives us 0. So remember, the sum of the oxidation number of all atoms in a neutral compound is always 0. Rule number 8. The oxidation numbers of all the atoms in a molecule or ion is equal to the charge of the molecule or ion. So if you have a polyatomic ion, especially, the sum of the oxidation numbers of all the atoms in a molecule or ion is equal to the charge of the molecule or ion. For example, if you take nitrate, it has a charge of -1, right? So the sum of the oxidation number of nitrogen and that of oxygen should sum up to -1. Rule number 9, fluorine has an oxidation number of what? -1. It has always an oxidation number of -1, except the elemental fluorine, which has an oxidation number of 0. So I'm going to show you how to assign oxidation number to all elements in this chemical equation. So let us start from hydrogen. So what is the oxidation number of hydrogen in this case? Because it is bonded to what? To carbon, its oxidation number is +1. So I'm going to assign the oxidation number of carbon X. So by applying the rules that we have learned, so I'm going to multiply 2 by x, 2x, right? Plus 4 times +1 is 4. And this should be equal to what? Because this molecule is a neutral molecule, the sum of the oxidation states of carbon and hydrogen should sum up to 0. Therefore, 2x equals -4 over 2 over 2. Therefore, x is -2. So the oxidation state of carbon in this case is -2. What is the oxidation state of hydrogen? So remember, this is an elemental hydrogen, meaning it is what? Bonded to hydrogen by sharing electrons, not losing or gaining. Therefore, the oxidation number of hydrogen is 0. So similarly, what is the oxidation number of hydrogen in this molecule? And this molecule is +1. So because we don't know the oxidation state of carbon, we'll assign it X. So let us multiply. 2 times X is 2X plus 6 times 1 is 6 equals 0. 2X equals -6. X equals, if you divide both sides, it will give you -7. So its oxidation number becomes -7. So this is how you assign oxidation number to all the elements. Alright, second example. So I'm going to start from here. What is oxidation state of hydrogen, elemental hydrogen? It is 0. What about copper? Similarly, it is 0 because it is in free state. Alright, so what is oxidation state of oxygen? It is -2. The oxidation state of copper, because we don't know the oxidation state of copper, I will assign the oxidation state of copper X. And then what is oxidation state of hydrogen in this case? +1. And the oxidation state of oxygen is -2. So let us calculate the oxidation state of copper from copper to oxide. X minus 2 equals 0 because the sum of the oxidation states of all atoms in a neutral compound should be always 0. Therefore, X equals plus. So this is how you assign oxidation numbers to elements. Let us assign oxidation number to all elements in each of these. So I'm going to start from sodium. What is the oxidation state of sodium? Remember, group 1A elements have an oxidation number of +1. And I will assign this X. What about the oxidation state of oxygen? It is minus. Now let us calculate the oxidation state of iodine. So because I have one atom of sodium, it is +1 plus X minus 6 should give you 0, right? Why? Because the sum of the oxidation states of all atoms in a neutral molecule is 0. So if you add this, X will be +5. Let's assign oxidation state to this compound. What is the oxidation state of potassium? +1 because it belongs to group 1A elements. And I'll assign the oxidation state of chromium to be X. And for oxygen, it is -2. Therefore, 2 times +1 is +2 plus 2x minus 14 equals 0. So if you add this, 2x equals +12 over 2 over 2. If you divide it by 2, you get +6. So the oxidation number of chromium in this compound is +6. Alright, now I'm going to assign the oxidation state of manganese X. And what about the oxidation state of oxygen? It is -2. Remember, this is a polyatomic ion with a charge -1. Therefore, X minus 4 times -2 is 8. And this should be equal to what? the charge of the molecule, and that is minus 1. So if you take this to this side, it will be plus 7. So this is how you assign oxidation number to all elements. So in general, in a compound, the more electronegative element is assigned a negative oxidation number, whereas the less electronegative element is assigned a positive oxidation. Now it's your turn. Try this in your own and write your answers on the comment section. So that's all I have for today. So don't forget to like, share, and subscribe for more chemistry videos like this. See you in the next video.